In this module, we will get our feet wet with the science of cryptography and its applications. We will define some key terminology, classify subtypes of the field, and end with a discussion of some important considerations that come up when designing applications that use cryptography. Cryptography is about hiding information in secret codes to make sure that anyone except for the intended recipient can't access it. A very simple secret code was used in Boston in 1776 to communicate a message to Paul Revere that the British were coming. The code was based on the number of lanterns in the church's bell tower, 1 if by land and 2 if by sea. Today, when most people hear the term cryptography, they consider it a slang associated with spy novels and movies. However, when you consider that has turned the tides of war, such as the cryptography used in the Enigma machine in World War II, and when you consider that every time you make a payment online, every time you talk to your family on your cell phone, every time you post something embarrassing on Facebook that you wish you hadn't, you are using cryptography. It is then that you will realize that cryptography is one of the most critical infrastructural pillars of our modern infrastructure. It is the guardian of your security and privacy. Unfortunately, cryptography can be used for bad as well as for good. Among other reasons such as human error, data breaches due to cryptographic failures, or lack of it, are dominating headlines in recent years. The figure on the left depicts the recorded number of data breaches and records exposed in the US between 2005 and 2017. The number of data breaches have reached the highest figures to date in 2017, with nearly 179 million records exposed. CryptoLocker, GhostMiner, Heartbleed, WannaCry, Backoff are the scary names of some of the recent software bugs and malware that directly use cryptography for evil purposes. The game of encrypting and decrypting is the same as with keys and locks. You lock what you need to be safe and you use the key to access that item. When we encrypt a piece of information, we simply put a lock on that information. Obviously, the only way to access that information should be via our key, which is called the decryption. In cryptography, the cryptographic algorithm, or simply algorithm, is used to mean a particular type of secret code that changes each letter of our message into another letter or message or symbol. Keys, also called passphrases, are a piece of information, a parameter so to speak, that determines the functional output of the cryptographic algorithm. The keys can be of varying sizes. A system that relies on one or more algorithms to implement a security service is called a crypto system. Typically, a crypto system consists of 3 algorithms, one for key generation, one for encryption, and one for decryption. The term cipher is also used to refer to a pair of algorithms, one for decryption and one for encryption. So you probably believe me by now that cryptography is important. The important question now is, what is cryptography and what is part of cryptography? We look at the different aspects and branches and we see that the main notion is cryptology, not cryptography. Cryptology splits into 2 sub-branches. Cryptography is the important one and the other is cryptanalysis. Any clues as to what is the difference between the two? Well, the answer to that is, the first is the good guys and the second branch is the hackers trying to break in. So if we drill down into cryptography, we have symmetric, asymmetric, and protocols. Symmetric algorithms are the more commonly known branch. Two parties have an encryption and decryption method for which they share a secret key. All cryptography from ancient times until 1976 was based exclusively on symmetric key methods and is still in widespread use. Asymmetric algorithms, also known as public key algorithms, are an entirely different type of cipher introduced in 1976. In public key cryptography, a user possesses not just one but two keys, a secret key as in symmetric cryptography, but also a public key. Asymmetric algorithms can be used for applications such as digital signatures and key establishment, and also for classical data encryption. Cryptographic protocols deal with the application of cryptographic algorithms. The Transport Layer Security Scheme, TLS, which is used in every web browser, is an example of a cryptographic protocol. Cryptanalysis is also called code breaking. One would think that cryptanalysis is not a strict scientific discipline, but in fact nowadays it is not just performed by hackers but conducted by cyber analysts as well as academic researchers alike. If people who try to break ciphers didn't exist, then we will never know whether crypto systems are really secure or not, and therefore it is an integral part of cryptology. Now, cryptanalysis can be divided into three main parts: classical, which either exploit the underlying mathematics and the structure of the cipher, or treat the cipher as a black box and brute force all possible keys; implementation based, which look for bugs in the way the crypto system has been implemented; and social engineering. Social engineering attacks exploit the weakest link in the crypto chain, that is, the humans using the system, using bribes or trickery, and are historically the most successful attack technique known. Cryptography is not the ultimate solution to all security problems. It is only one aspect of cybersecurity. There are many other aspects to building a secure program. As such, cryptography encompasses a set of building blocks for our security approach. Now, there are several layers of explanation to this. First, cryptography under many conditions builds upon some algorithms, and when people design these algorithms, they think they are safe. Now, after 10 or 20 years of research and development, they say, okay, we made these assumptions which were wrong, and it's no longer safe. So it's very possible that we could have been using some insecure encryption algorithm in all our applications without knowing about it. Second, even if the encryption algorithm is safe, we still face many challenges. Put it on paper and prove that breaking it is beyond our computational capabilities. Tomorrow, if aliens from Mars land in here on Earth, we assure you that even if they have a super duper computer, they still cannot break it, and we can prove that. Now, eventually you would need to translate this paper-based proof into a computer program, and when people implement things, we all know that weird things could happen. They could embed bugs in the software implementation, and you could end up using an insecure implementation of a secure cryptographic algorithm. Third, last but not the least, the reason we say that cryptography is only a building block to implementing security. Let's motivate this problem with an example from car manufacturing. Consider that you buy the most expensive parts from car factories around the world and put them together to build a car. Are you going to have the best car in the world? Well, not necessarily, right? Because you have to put the right parts in the right places. Now, the best parts or the most expensive parts put in the wrong way will not give you the best car. And the same thing for cryptography. You pick different components to build a security approach, and you make sure your information and your infrastructure is secure based on those building blocks. You don't necessarily want the best ones, you want the most feasible ones. Let's say I have an encryption algorithm that uses 1024 and 2048 bit keys. I'm not going to say that using a 2048 bit key is always better, right? Because it depends on whether I'm going to use those 2048 bit keys on a server, or am I going to use those keys on my smartwatch. A smartwatch may not necessarily have the computational capability to be able to process such large sized keys. In conclusion, it's very important when considering cryptography in how that cryptography is going to be used ultimately. What's the big picture? What's the operating environment? What are the kinds of software modules that are going to work with those cryptographic algorithms? Those are some of the things that need to be kept in mind when considering cryptography for your security approach. Thank you.